All right, let's take a look at a couple more problems. So this problem right here, currently 1,800 people ride a commuter train each day and pay $4 per ticket. So this is our P, the price. The number of people X, which represents the demand, willing to ride a train at price P is given by the equation X equals 600 times 5 minus square root of P. This represents your demand function because X, number of people, is the demand. So that represents our F of P. Now the railroad would like to increase its revenue. So if the railroad wants to increase its revenue, should the price of the ticket be raised or lowered? So to answer this question, we need to know what is the elasticity of demand at the price of 4, okay? Which means that we have to use our formula. E of P is equal to negative P times F prime of P divided by F of P, okay? So if this is our F of P, let me just rewrite that. F of P is equal to 600. Now I want to distribute this, okay? So 600 times 5 will be 3,000 minus 600. And then the square root of P, I'll write it down as P raised to 1/2 so that I can easily apply the power formula when I get the derivative because we need to get the derivative of this. Okay, so derivative of 3,000, that would be 0. Derivative of 600 P raised to 1/2, we multiply that exponent by negative 600. So let me write it out. Negative 600 times 1/2, and then times P raised to negative 1/2. 1/2 minus 1 is negative 1/2. So rewriting this, F prime of P would be equal to 600 divided by 2, that's negative 300. And then the P raised to negative 1/2, I'll just put it into the denominator and change it into a radical. So F prime of P is equal to negative 300 over square root of P. All right. So now our E of P would be equal to negative P times F prime of P. So that's negative 300 divided by square root of P. Over F of P, which is 600 times 5 minus square root of P. Okay. Now, how do we simplify this? Let's use some algebra. So negative, that becomes positive. And then remember when you divide P divided by square root of P, you have to subtract the exponents. So that becomes square root of 300 times square root of P. Because this P cancels out with this, and that becomes square root of P, or P raised to 1/2. Over our denominator, 600 times 5 minus square root of P. We can still simplify this, right? Because the 300 and the 600 would cancel out, and we will get E of P is equal to square root of P over, that becomes 2 times 5 minus square root of P. Okay, so this is the simplest form of our elasticity of demand function. Now again, remember we want to find whether this is elastic or inelastic at price equal to 4. So we want to evaluate the elasticity of demand at 4. Okay, so we have square root of 4 divided by 2 times 5 minus square root of 4. Now, can we without simplifying, can we just plug this into here? But of course, we can do that too, okay? And yeah, we can do that. So what do we get here? P of 4 would be equal to 2 over 2 times 5 minus 2. Square root of 4 is 2. So this gives us 0.33. That's 1/3. So 0.33 is less than 1. And what does less than 1 mean? If the elasticity is less than 1, it means that the product, in this case, is inelastic. So when you increase price, the revenue would increase. The increase in price, increase in revenue. So if the railroad wants to increase the revenue, then they should increase the price. All right, let's take a look at this one. Next example. An electronic store can sell X equals 10,000 over P plus 50 minus 30 cell phones. This is the demand function. This is our F of P, okay? At a price P dollars per phone. The current price is 150. If the price is slightly lowered, will the revenue increase or decrease? Okay, so first let's find our F prime. So let me rewrite F of P, okay, so that we can apply the power formula. Okay, bear with me here. This part can be written as 10,000 times P plus 50 raised to negative 1, right? Then minus 30. So when we get F prime of P, you multiply 10,000 by negative 1, that becomes negative 10,000. And then P plus 50 raised to negative 2, exponent minus 1. And then the derivative of 30 is equal to 0. So we got this. Okay. Now, let's keep it at that. So our E prime, E of P is equal to negative P times F prime of P. So times negative 10,000. Let me use negative 10,000 times P plus 50 raised to negative 2 divided by F of P, which is 10,000 over P plus 50 minus 30. Okay. So let's do it this way. We want to make this positive. We want to make this positive. So negative times negative, that's positive. We'll just rewrite this as 10,000 over P plus 50 squared, okay, over 10,000 over 150 plus 50 minus 30. Okay, that's more like it. So 10,000 times 150, let's see, 10,000 times 150, that's equal to 1, 2, 3, 4, 5, 1, 5, 1, and then we have 5 zeros. Okay, over that's 200 squared, which is equal to 40,000 divided by, so we have 10,000 divided by 200, which is equal to 50 minus 30. Okay, so this is more like it. So from here, we can cancel out 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros to make it, to reduce it. So we can divide 150 divided by 4. It's equal to 37.5. So we get 37.5 for the numerator divided by 20, right? So 37.5 divided by 20 gives us 1.875. Okay, very good. So we get 1.875 is greater than 1. Okay, and we say that if E is greater than 1, then it is elastic. And if it is elastic, raising prices decreases revenue. So if the price is lowered, will the revenue increase or decrease? So meaning if you lower the price, what happens to the revenue? The revenue would increase. Oops. Revenue would increase. Class, if you have any questions about this, I know this is a bit long, please write your questions on the discussion forum.